Well, we have the general forms of quadratic equation. This is a quadratic equation because of that squared. This is a quadratic equation because of that squared. So we are looking at the general equations that we have, which is ax squared plus bx plus c, together with this vertex form. We are calling it a vertex form because the value of p is responsible in the what? In the point at the vertex and q as well. So that is why this format is called a vertex form. Now, I just want to show you the relationship between this form as well as that form, because at the end of the day, we always would like to deal with few unknowns, like for example a, b and c. It would be better if we have a, b and c only in our one equation than to have a, b and c, q as well as q and p. Now I just want to generate a formulas that are going to combine the relationship between these two forms. For example, I just want to write a x squared, which is equal to bx plus c. We know that this is also equivalent to this vertex form, which is written as x, this is x squared then plus q. How are they equal to each other? Let's find out by trying to expand that one. Let's have a outside, then we have x squared, then we have minus 2xp, then we have plus p squared. By expanding this binomial, then at the end we add that q. Now, what we have thereafter, let's try to remove the brackets by expanding or distributing that value a. We have a x squared, then minus 2 a p times x, then plus a p squared. A times p squared is a p squared, then just plus q. So we now have that. So you can see now it is close to this form because you can see you have the coefficient of x squared, which is a. The coefficient of x squared is equal to a. So you can say a here is equal to a there. So what is b here? B, we have b, which is equal to, what is the value of b here, which is the coefficient of x, which is negative 2ap. Negative 2ap, let's write negative 2ap. These are the coefficients that we are writing. So we can be able to find the value of p, because you are looking for p, we're looking for q as well. Hence we have said a is just equal to a. So what is the value of p? What is the value of p? So p is going to be equal to, when you divide by negative 2a both sides, you're going to have negative b over 2a. This is what you are familiar with from the equation of the asymptote. Now let's go find q, and q is the what? Q is the constant, and we have c, which is a constant. But what is the constant to this generalized expanded form? We have c, which is equal to, c is a constant. Any value that is not multiplied by x is a constant. So we have a p squared then plus q. So if you look for q, q is going to be equal to, you have c minus a then p squared. Fortunately enough, you have the value of q of p, which means you can substitute now by the value of p by having what? By having c minus a times, what is the value of p? The value of p is negative b over 2a, which means you have negative b, which means you have negative b over 2a, but it is being squared. Well, now what can you say? You have to try to minimize or to simplify as far as possible. So our q is going to be equal to c is equal to, this is going to be, we have this what you can say, we have negative, this is a negative, then we have b squared there. When you square this thing, is going to be positive. Then here you're gonna be having 4 times a squared, 4 times a squared, 4 times a squared, but 4 times a squared, let's put a here for some strange reasons. Then this a is going to cancel one of them there. Then your q is going to be equal to, let's have negative c minus b squared over 4a. So you may be familiar to this as well when you were solving using what you call the completing of square. You may be familiar to this and to that as well, but now I just show them by relating the coefficient of x squared, x, as well as the constant. So this is what you have. So you can write this formula now in form of what? You have a into x, then minus p, then your p is minus b over 2a, so minus and minus, you're gonna have plus, then b over 2a, then all brackets squared, then therefore plus q, then your q happens to be this, so you have plus c minus b squared over 4a. So now you don't have any q, you don't have any p. So you can use this formula now when you are asked or you are given a function in this form and you are to write it in a vertex form. So when you are looking for these things, let's say you have just a general question, you have what? You have example, what you have, let's say you have 2x squared minus 4x, then minus 6. Let's say you have this one, then you are to write it in a vertex form. And let's use this formula. Then what is your value of a? The value of a is just 2. Then you open brackets, so you have x. What is the value of b? The value of b is just 4. It's just negative 4. So we have negative 4 divided by 2 times a. What is the value of a? The value of a is just 2. So 2 times 2, then all close brackets. So you all have squared, then plus. What is the value of c here? The value of c is negative 6. So instead of just saying plus, so we just have negative 6. Then what is the value of b? The value of b is negative 4. Negative 4 squared is gonna be, so we have negative 4 squared, which is just gonna give you 16. This negative is for the formula. Then negative 4 squared is gonna be just 16 divided by 4 times a, which means your a is 2. So at the end of the day, you end up having 2 in brackets. What you have x. This one is going to be negative 4 divided by 4 is just going to be 1. So we have this squared. Then therefore we simplify that one. 16 divided by 8, you just get a negative 2 minus 6, just going to get negative 8. So this is the format that you have without completing a square. You just use this one by having this already generalized form from what you have there. So this is another way of finding the vertex form by using the coefficient correlation to when you are having these two equations. So I hope you will enjoy this way of dealing with quadratic equation. Otherwise, there is more interesting ways of dealing with a quadratic equation. Hence, you can generalize or generate some formulas using derivatives and all that stuff. So I think you enjoy this one as much as I would like you to. Otherwise, please keep on supporting, guys. There is more to come that is going to generate or create your interest or to make you feel at home when you are doing mathematics. Thank you, guys.